Hey guys, sorry, this is SyedaZaidi, and today I'm going to be talking about pre-calculus. And this chapter is chapter 8, which is basically the unit of 8.4, which is the determinant. So basically in this topic or in this unit, it's mostly about matrices. And matrices basically, it just kind of, I guess, has a sum, like example, like addition, subtraction, division, fractions, all those things. They are basically involved with this matrices, but it's mostly like addition and subtraction and multiplication too, and probably division if there is a equation that does involve division. So these all these things are involved in the matrices. There was also a topic I talked about with 8.1. It was talking about the matrices and how they develop together and how you get the answer and everything. But this one is just, it's kind of involved in matrices, but you're basically trying to find another equation to substitute the numbers in there. Like you have a matrix, right? And you have, like, example, 2 by 1 matrix. So it's like it's 2 columns. 2 by 2. Sorry, it's 2 columns and 2 rows. So basically, they have example like -5, -6, -7, -8. Okay, and you need like, they will give you like a formula, a specific formula you have to like remember, and you're gonna have to substitute all those numbers in that formula, and then to get the answer. Mostly, you would just get the answer by just solving randomly in the matrix, right? That was supposed to be in the last 8.1 topic I think I talked about recently. But this one is about basically substituting those numbers in a formula in order to get the answer. So it's pretty it's step forward, it's kind of like just straightforward, But today I'm going to show you guys what that formula is and how we are going to be substituting that. So in this review, we're going to talk about the coefficient matrix. Now this one is really different. This one is a 2 by 2 matrix. It's A equals A1, A2, B1, and B2. Now they involve A1 and B2. Now these two letters, they are going to be substituting the numbers that we find in the matrix. So now this one connects to the equation. So that this is just an example of the numbers into letters. This one is the determinant equation, or the formula we're going to be using in order to substitute the numbers from there. So the formula for this one is determinant A. It's like shorter for det or determinant, or det is basically shorter for determinant. So it's determinant A, so the substitution for A right there, equals to A1 B2 minus A2 and B1. Now this formula is basically where you're gonna have to substitute those numbers, but wherever they're located in this kind of format, you're gonna have to substitute that. It's really straightforward. But I'll show you when we get into that in a minute. The cofactors. Now these cofactors are very important to learn about because you're gonna be using them too. I'm gonna be showing you an equation that will be involved with cofactors. Now there are different kind of sums or different kind of numbers or different rows and columns that you're gonna be involving with. Now the most common one we're gonna be doing in this video is gonna be talking about the 3 by 3 matrix, and then we have the 4 by 4 matrix, and then the n times n. Now n times n is not really common that much, but people do still use it for solving the matrices. But these two are mostly the common ones. But today we're just gonna be talking about this one. But when you learn this one, you will most possibly know how to solve in this one too. But these are just the reviews that you will need to review by in order to solve the problems. So let's get on with it. Okay, so this problem is very, very easy, but I'm just gonna give you guys an example of how this determinant goes by. In this question, it says that the absolute bracket, so in the brackets inside is 10. If you want to find the determinant, it would just be negative. So you would just involve -10. That's basically just the answer. But I just wanted to remind you guys that whenever it has a one sum, it's always -10. It's always negative. If it's a negative one, it would be probably positive. But whenever it's a positive 10 in the brackets, it's always gonna be a negative answer. If it was like 8, it would equal to negative 8. If it was in any sum, if it has a positive absolute and under the brackets, it would be, inside the brackets, it would be negative 8. Okay. Okay, so the second question we're talking about is find the determinant of the matrix. And so this is a matrix that you will get in, this is like a common kind of 2x2 matrix. So let me just put it there so you guys know what kind of, so basically 2 is the rows, 2 rows, right? And 2 columns, which would be 2, 2. So basically 2x2, right? So basically, in the numbers are 5, -3, 2, and 7 in a 2x2 matrix. Now, as a formula I talked about before in the review, you can always go back and listen to how you need to substitute these numbers. But today, I'm gonna also be, just in case you guys forget or you don't want to review, I'll just tell you guys over here. So, now the formula for the matrix in order to find the determinant answer, it is A1, A2, B1, and B2. Now 5 and A1 are, 5 is A1, -3 is B1, 2 is A2, and 7 is B2. Now these words do define the numbers in this matrix. Now the thing is that I don't know, but I've heard that some people change the matrices and they evaluate into something else. That is totally wrong. You guys should never change the answers or change the numbers in the matrix that you're already given. If you do change the numbers, you will definitely get it wrong, and that's how you won't ever figure out what happened. So don't ever mix up the numbers. Some people mix up the numbers and they're just like, okay, that's done. That's not done at all. You did it completely wrong. So when the question gives you the matrix, stay with it. Keep it as it is and just transform it to here, okay? Now to find the determinant. Now the question is asking for the determinant, not to solve the matrix, not to mess with it, but just to find the determinant. That's all. Now determinant is, the formula for determinant, as I talked about before, is A1 minus B2 minus A2. Oh, sorry, I'm so sorry. That's actually, I don't know why I put minus over there. My bad. So it's A1 minus B. Okay, sorry. A1 and B2 minus A2 and B1. Pretty sure that's a formula. So now determinant is basically short for. Oh, sorry. DET is basically short for determinant, and you see right. Okay. So now the formula is A1. So you see how they basically contribute to the matrix right here. You see that? So they basically they basically separated the numbers and put it on here. Now what they did in order to make this formula is that they basically cross multiplication, right? This is just like the same thing but inside the matrix with the words. So it's gonna be like, as I put the arrow, this is how it's going. So it's A1, B2, A2, and B1. It's kind of like that, okay? So now we're going to start substituting the numbers into the formula. So it will be, so A1 is 5. We always have to multiply. Never, okay, in these two, you see how it's multiplication. There's nothing else. There's no sign. There's no multiplication sign. There's no division sign. There's no plus and minus. It's just together. That means it's a multiplication, okay? Now 5 is A1, right? A1's right there. We got that. Okay, let's do check mark. Or let's just cross it out if you want to. B2 is right here. So that means that the B2 will be 7. Okay? Now, minus. Now you have to put the minus sign right here. Okay? Don't put it over here. Put it in the middle so you know what you're subtracting. A2 is right in the left, like below in the left part. So that'd be 2. So minus 2. And B1 is right here, which would be 3, or -3 actually. Now we just have to solve it. So let's see. 5 times 7 is 35, and 2 and -3 is what? 2 and negative 3 is negative 6. So it's basically going to be like this. So then you have to add it. So 35 plus 6 would be what? 41. So 35 plus 6 equals to 41. And this is your answer. So this is kind of like a step-by-step process. There are 2 steps. First, identify what word belongs to what number. Then you have to put the formula and just substitute the formulas. Just substitute the numbers to the formula, okay? And this is how you solve equation number 2. Okay, so this part is about cofactors and minors. Now, minors is basically involved with the matrix, but when I talk about cofactors, there's actually they have specific like numbers of what you should have, like the matrix numbers. For example, if it's a 3x3, you should have 3x3, or if it's 4x4, you should have 4x4. If it's n by n, you should have n by n. But other than that, like, if it's like 2x3, that would be wrong. It has to be the same number. But for this one, this is 3x3, so we have 3x3 matrix, okay? And now we're gonna basically solve all these all these factors that we have to substitute or find the answer for. So in minors, minors are very, very, very kind of step complicated, but when you practice more of it, you will get used to it. So I practiced a lot for this, and I actually understood how to do it. So the minors part is that we have to use specific strategies in order to solve. So example, if you want to find out, M11 is the first matrix that you should find first. The first minor. So this is 11, 20, and 33. Or sorry, 11. It's basically this is 11 part. This is 20, and this is in 30s. But in most of the times, it will be like 11, 21, and 31, and this will be like 12, 22, 32, and this one will be 23. 13, 23, and 33. So, but so M11 to M33 are the only matrices the minors that you have to find. I'm sorry, I'm getting all these words mixed up with my mind. But M11 through M33 is the biggest or the longest you can go by, because if you have 4x4, I think there'll be more, but in this situation, we only have 3x3, so we're only going to focus on these 4 instead. But you could do the other part too, but for now, we're just going to be solving only this part. So let's get started. This is basically row, actually this is row 1, this is row 2, this is row 1, row 2. So it's kind of like a mix, okay? So first step we're going to be doing is that first what I do is that I circle the first sum. When I circle the first sum, then I'm going to be talking about, okay, well, we can try going by here and here. So let's cross this out, okay? It's crossed out. We're not going to be using all this. We're not going to be using this sum at all, okay? We're only going to be focused on 8, 0, 5, and 7. So we're just going to cross that out, okay? Now, 8, 0, 5, and 7. Let's think about that. Now, remember like the second question we talked about was that there's a 2x2 matrix. That means that we have to find the determinant of that, right? So let's equal to that by 8, 0, 5, and 7. Now let's find the determinant. So the determinant over here is 8 times 7 is, okay, actually let me just do step by step so you guys know what I mean by that. Determinant A equals, so let's do the formula, A1, A2, B1, and B2. So what we're gonna have to do is that we're gonna have to do so A1 is 8 times by B2. So B2 is 7 minus A2, which is 5, and B1 is equal to 7. Sorry, so 7 times 8 is 56. So 56 minus 0 is basically equal to 0, right? Okay, so sorry about that. I don't know what happened, but basically it's equal to 0. So that means that, I'm so sorry. That means it's equal to 56. Sorry, I was thinking multiplication. Sorry, it's 56. So that means that the 11 is 56. So the minor 11 is 56. Okay? Now, if you do that by step in other ones, so let me just do another one real quick. Actually, you know what? I'm going to show you guys all of them so you guys know how to do this step by step, okay? Since this is your first time, or if you're just trying to learn. So now we have is that we're going to try, okay, this is going to be a whole mess. So we're just going to comprehend with this part, okay? Just bear with me. It's kind of messy right now. I'm very sorry about that, but we have to go through that if I want to show you how to do that properly, or if I... Okay, this was 9, I'm pretty sure. Now, the second part you're gonna have to do if you want to find M12 is that we're gonna be focusing on this part now. It's basically like it's just like 1, 2, 3, you know. So we're gonna cross this out, and we're gonna cross this out, and we're gonna cross this out. So now it's 2, 3, 0, 7. So now we're gonna do 2, 0, 3, 7. And never change wherever it is. Don't be like 2037. No, leave it as it is and just substitute it, okay? Now, in order to find this, now the D, let's just put D as the determinant. So D would be so A1 is 2 times by B2, which would be what? 7, right? 7 minus A2, which is 3. So let's put 3. And B1 is 0. Oh, another one. Okay, so 14. Okay, so it's equal to 14 and minus 0. So I mean it's just 14. Okay? This is very much not that hard to subtract. Okay, okay, I should have ruined the matrix part right here. Okay, you know what? Let's just get this out. Okay, let me just erase this 3 by 3. I think it's a little confusing right here. This does take a long time to figure out what the answer is for each of these minors and cofactors, but when you get used to it, it'll be more easier in order to solve, okay? Now let's find M21. Now, what I talked about, okay, listen. 12 is the first row. Okay, 12, 13, 11, 12. I'm so sorry about that. I am very much mixing this up. 11 to 13 is, so this is 11, 12, and 13, okay? And then you have 21, which would be the second row, and then 31, which would be the third row, okay? Now, it'd be like 21, 22, 23, and this one would be 31, 32, 33, okay? In a 3 by 3 matrix. So, now we have to find 21. So 21 is what? 21 is basically, it's just the same step as we did on the first row. So it's like 2 here. I'm so sorry. So now we're going to cross out this part, and basically this part, I'm guessing. Let me think about this, sorry. Because I'm 20, okay, so 8, it'll be 1, 9, 5, and 7. Okay, yeah, so it'll be like this. Okay, so now let's try solving. So it's gonna be like this and just cross out blank, okay? It's gonna be like that. Okay, so let's get started. So it's 1, 9, 5, and 7. Okay. So that means that the D would equal to, so, okay. So D, now let's use the formula again, right? So it's 1 times by, now B2 is right here, right? So 7. 7 again, wow. Now it's A2, which is 5, and then times by 9. So 7 minus 45, which is negative 38. Okay, so that means that the M21 would be negative 38. All right, now let's go on the next number, which is the last one. Yay. Okay, you know what? Let's just leave it like that, because we're not gonna be Actually, we are going to be so focused on that, are we? Okay. Pretty sure that was 3, right? Alright, sorry about that, just had to fix a little bit. But now we got that, right? So now we have to do M21. Now M minus 21 would be right here basically. So we're gonna have to exit out here would be 8. So we have to 8 is the number for M21, right? And when we do that, what should it be? So basically we're gonna do this, we're gonna cross out all of this, and then we're gonna cross off this in the middle. So it's kind of like a T. So this would equal to -7, 9, 3, and 7. Okay? So D equals to, okay, so A1 and B2, A1, B2, cross multiply, right? -7, 7, 3, and 9. -3 and 9, which is A2 and B1. Now, -7 times 7 is -49 minus 20. Well, actually, it would be minus 27. Oh, no, sorry, it would just be minus 27. Okay, -49 minus 27 is what? Okay, so -49 minus 27 will be equal to -76, okay? So, basically, now, on the cofactors part. Now, the cofactors is pretty much the same answer, but they sometimes have a different kind of negative, if it's like a negative or a positive. So, sorry about that. So, in this problem, it's most likely going to be all positive due to how the matrix is left with. So, let's just say that, okay, so there's actually a specific formula that they use. It's mostly a formula like, okay, so it's like the sum right here, right? So it's gonna be, okay, sorry about that, my camera keeps cutting off. But okay, basically overall, actually I don't think I think the specific formula for like a different topic, but this topic I don't think it has like a formula to solve it. But basically it's just like the opposite of this. So, but in this kind of matrix, I think it's gonna be all positive numbers. From what I've been doing problems with mine so far, to be honest. So I think I'm pretty sure it's gonna be 56, 14, 38, and 76. So this is the cofactor, this is the minor, it's just like the opposite, but since of the matrix, it's gonna be all positive instead. But this is how you solve the the minors and the cofactors of the matrices.